Okay, we're back with part 2 of physics module 15. So we were supposed to find the current in this parallel circuit with a 6-volt battery and two 2 ohm and one 3 ohm resistor. And so we had already found the resistance of 3/4 of an ohm. Now we were going to find current. So using Ohm's law, V equals IR, our 6-volt battery divided by our 3/4 of an ohm resistance tells us current. And when you do that, like 6 times 4 divided by 3 gives you 8. So 8 amps is our current. So I told you in a series circuit, current is always constant, but in a parallel circuit, current divides. And so, right, the electrons choose this path or that path or that path. And so current will divide up. So we would, in a parallel circuit, be able to determine the current in any one of the given resistors, which might change. And so in this case, since we have 8 amps of current, we would have, we can find the current for each resistor. So 6 divided by 2 gives us 3 amps for this resistor, same for this one, 3 amps. And then 6 divided by 3 gives us 2, right? So we'd have 3 amps of current, 3 amps of current, and then 2 amps of current in those resistors. And that adds up to our 8 total amps, right? 3 plus 3 plus 2 is 8. And so Ohm's law lets us, in a parallel circuit, determine the current in each resistor, but it's not necessarily constant. So let's see. We did that. Okay. So let me change the board. Okay, so now we're going to talk about the concept of power. So light bulbs are familiar to you. Hopefully you've bought them, put some in to replace burned out ones. And you know that when you purchase a light bulb, you're going to basically look at the wattage of the bulb. And so power's unit is the watt. So generally when you buy a bulb and you're looking at wattage, a 40 watt bulb would be dimmer versus a 60 watt or 100 watt bulb. So for us, we have lots of relationships here, and you can kind of see how they all relate so that we can form our next equation, which is P equals IV, power equals current times voltage. So power is energy over time. Voltage is energy over charge, and current is charge over time. And you can see we could like multiply voltage times current, and the charge would cancel. So you'd end up with energy over time, which is power. So voltage times current is power. P equals IV. So here's your next task. Draw a parallel circuit with two 2 ohm resistors. Find the current for each bulb, and then the total current. Find the power for each bulb, and then the total power using that equation. So hit pause, try that, and then we'll come back and do it. And use a 6-volt battery. Okay, so we've drawn our circuit here. We have a 6-volt battery. We have two 2 ohm resistors in parallel. So the electrons can choose one resistor or the other. To find the current for each bulb, then we just use Ohm's law. V divided by R equals I. 6 volts divided by 1 resistor, which is 2 ohms, gives us a 3 amp current. Find the power for each bulb. P equals IV. So for each bulb, we have a 3 amp current, a 6-volt battery. So our power will be 18 watts for each of those bulbs. And then for total current, I did it this way. I found resistance for a parallel circuit. You do the 1 over R equals each resistance reciprocal added up. I found resistance to be 1 ohm. So 6 volts divided by 1 ohm gives us a 6 amp current. So total current is 6 amps. I could have just added up the 3 amps for that resistor and the 3 amps for that resistor and gotten 6 amps as well. And then for total power, P equals IV. So current is 6 amps total current. The battery is 6 volts, so 6 times 6 is 36 watts. I also could have added up the power for the two bulbs. 18 plus 18 is also 36. So that is the basics of that. Also, we have another equation that you want to know. P equals I times R squared. So if you use Ohm's law, V equals IR and P equals IV, you cancel those V's. That's how you end up with I squared R for power. You can derive that with Ohm's law and P equals IV. Let's see. So that's all a review. I'm going to write a couple extra problems for you on the board. Okay, so your problem is to find the resistance if you have a 6 volt battery and then you have a 4 ohm and a 6 ohm resistor. Draw them in series and in parallel and find their total resistance. So I'm going to hit pause, you hit pause, and we'll do that problem. Okay, so if we draw our circuit with a 6 volt battery in series, we have a 4 ohm and a 6 ohm resistor. With a series circuit, we just add up the two resistances to find the total resistance. So 4 ohms plus 6 ohms is 10 ohms. With a parallel circuit, we draw them so that the electrons would be able to use either pathway. So we have our 6 volt battery and a 4 and a 6 ohm resistor. Then we use our equation 1 over R equals 1 over the resistors. Then I found a common denominator, and then I solved for R, and I found the total resistance to be 2.4 ohms. So you can see total resistance of the exact same bulbs with the same battery when they are in series is much larger, 10 ohms. And when you put those exact same resistors in parallel, that resistance goes down to 2.4 ohms. So huge difference depending on how you set your circuit up. So the bulbs here would be brighter. And we could also find current for this circuit exactly using Ohm's law. So we could do like V equals IR using total resistance for this one, right? 6 volts divided by 10 ohms would be our current. And 6/10 is 0.6, right? So our current would be 0.6 amps. And then if we did it down here, we would say current is 6 volts divided by 2.4 ohms. And I would need a calculator for that. Let's see what we've got. 6 divided by 2.4 is 2.5. So my current here would be 2.5 amps. And up here it was 0.6 amps. So current is much lower here in this series circuit than it is in the parallel circuit. Resistance is lower in the parallel than in the series. So I'll make a video for review questions and one for practice problems. Or maybe I'll just do a review. Well, I don't know. We'll see after class. After this video, I definitely want to do a lab video, but I think we might have to do a sim this year in 2020. So we'll talk about that on Tuesday, and I'll see you then.